Hello guys and welcome back to my channel. So I'm continuing, it's been a long time, so I decided to record another video tutorial based on the request of my new subscriber, and I hope this will be a beginning to many more videos to come. So I'm recording a new video for the Unit 2 chapter of the IGCSE Computer Science textbook, which focuses on data transmission and basically focusing on how data is transmitted from the sender to the receiver, and also the method of data transmission and why it is important for us to understand how data is transmitted. So we are going to begin. I would just like to give a note that I will kind of summarize through the theory part of this unit, because then I would like to focus on the practical part. So I will try to do a summarization of the unit as much as I can so I don't make this video too long, and we will do the practical work as well in terms of finding out, for example, how to find the right parity bits and what parity blocks are and the error checking methods. So that would basically be the practical part. Okay, so let's begin. So this unit focuses on how data is transmitted from one device to the other. A very important part of this unit is for you to understand the method of transmission, the direction of data transmission, and the error checking methods, which basically checks to make sure that data is transmitted correctly and is not transmitted out of synchronization. So data transmission technically can be either transmitted over a short or long distance, and essentially, as you can see here, there are three factors that affect the way data is transmitted. The first factor is you need to consider the direction of data transmission. So we're going to be looking at the different type of directions that we have for which data can be transmitted from one device to the next. Also, the method of transmission of data, which means how is data actually transmitted, and the method of synchronization between two devices. So looking at the first one, which is the direction of data transmission, data can either be transmitted using simplex, which basically means that it's transmitted only in one direction. And a typical example would be like when you're trying to send something from your computer to a printer, which goes in one direction, doesn't go in a simultaneous direction. We have half duplex data transmission, which basically transmits data in both directions, but not at the same time. So data either goes from A to B or it goes from B to A. And this is normally, for example, when you have a phone conversation with another person where only one person speaks. So basically you're talking to someone on the phone and you're speaking and the other person is listening, and basically the other person is listening to you. So your transmission of data frequency, sound frequency, is being transmitted over that connection. And then the other person speaks and you listen. So it is not a simultaneous process. One person has to speak and the other listens. Full duplex data transmission, which means it transmits data in both directions and at the same time, so simultaneously. So this would have to relate to not just a normal phone conversation, but a broadband conversation on a phone line. So like when you're talking on Skype, for example, you're having a conference where you can talk and the other person can talk. Of course, not to create some sort of confusion between the two of you, but you can basically speak and the other person can speak and you guys can hear yourselves at the same time. So it's like an A to B and B to A communication. All right, so now in terms of serial data transmission, now we look at the method of transmission. So that was the direction, which goes simplex, half duplex, full duplex. Now we look at the method of data transmission. We have a method called serial data transmission, which means data is sent, as it says here, one bit at a time over a single wire channel. So you can already tell that this would be a slower method of data transmission, but of course a more reliable method which avoids data from being skewed. Because when data is transmitted over a single line or a single channel, one bit at a time, it means it's going to be transmitted accurately to arrive the receiving computer or receiving device correctly, even though it might take more time. So this type of data transmission method is very useful mostly for long distances. And like I said, even though data is transmitted at a slower rate than parallel data transmission, it is more reliable so that the data does not arrive out of synchronization. So here they give you an example of this type of data, where this type of data method is applied, which is the serial data transmission, and it is normally applied when data is sent from a computer to a modem over a telephone line. The alternative to this kind of data transmission method is the parallel data transmission, where we have several bits of data are transmitted down several wires or channels. And that basically makes it faster for the data to arrive because it can be broken down into several bits. But the problem is sometimes data could get skewed over this method of transmission, which is why it's most likely recommended and suitable for short distances. So like I said, this method of data transmission would work well for short distances, which means that so that you avoid data from being out of synchronization. It is, however, a faster data transmission method than serial. And this is an example of this kind of data transmission method is when you're sending data to a printer from a computer over a ribbon connector. And we're going to show you what a ribbon connector is. As you can see on this figure 2.3, this is a ribbon connector. And you can see that it's divided into several lines. These are kind of like the several channels in which data is being transmitted. For example, like they say, when you're trying to send printing jobs to a printer from your computer, of course, those printing jobs or files you're sending will be transmitted across several lines or channels. Okay guys, now we move to the USB. So we're going to be looking at a very common example. So I don't know if you guys have ever take note of this, but the USB actually makes use of serial data transmission, and you guys already are aware that serial data transmission method means that data is transmitted one bit at a time. So that's basically going through one single channel. So we're going to be looking at that. We also see that parallel data transmission in opposition to serial is used in the internal electronics of the computer system. So we know that the computer system internally is made up of the CPU, the memory, the processor, and all that is on the motherboard. So all of those integrated circuits inside of your computer system make use of parallel data transmission. You can imagine why, because that's going to make a faster transfer of data. So the speed in which data is transmitted will be faster. Because of course you do a lot of functions on your computer system. You open multiple applications, you open multiple files, you sometimes stream as well. All of that requires a high speed of data to be transmitted, of course, and such. This is why parallel data transmission is used in the internal electronics of your computer system that basically transfer data between the CPU and the memory, and also the communication between all of the integrated circuits that you have on the motherboard with other internal components of the computer system. So like I said, this allows for a faster data transmission, which could be achieved over a single line, with a single line, because you have different, parallel basically has multiple lines, so you're sending the data across those multiple lines. One thing you should take note of is with parallel data transmission, an internal clock is used to be able to make sure that data does transmit in a specified amount of time so that it is high speed, but at the same time data is transmitted correctly. So it is synchronous in nature. Okay, so moving on, the last part would be our type of synchronization methods. If you guys remember from the beginning, we said one very important thing about this chapter to ensure data is transmitted correctly and to understand how data transmission works is that we need to know the direction, which we saw with simplex, half duplex, full duplex. We also need to know the method of transmission and, of course, the method of synchronization. So synchronization would be the method that we ensure or data is ensured to arrive correctly. So the two types of synchronization methods in which data can be transmitted is the asynchronous or a synchronization data transmission method, which basically refers to data being transmitted in an agreed bit pattern. So with this one, there's something called control bits. As you guys already know, the computer does not understand anything other than binary, which means basically ones and zeros. So when data is transmitted, it is transmitted in a set of bytes, and we know that one byte is made up of 8 bits. With this kind of data synchronization transmission method, which is the asynchronous, it involves data being transmitted whereby there is a start bit and there's a stop bit, guys. And what that means is when you're sending a message, for example, you're sending an email from your computer to your friend's computer or someone else's computer across the world. Of course, all that text information that you're sending, which is basically made up of ASCII characters, and these are characters that are on your keyboard that have their own representation of hexadecimal values, which then get converted into binary. And of course, all this is done internally in your computer system. So that data, let's say you say hello, for example, that message alone, when you send it across, that hello is being translated and converted into binary. And so that data has to arrive to the other sender on the other side as hello. So with this kind of asynchronous data transmission, there is a starting bit, which means that there will be a bit of 1 or 0 that will be at the beginning of that hello, which has been converted into binary. That signifies that that is where the word or the message starts, and there will be an ending bit that also signifies where the word or the message ends. So these two starting and ending bits are known as control bits, and they're usually used with this kind of data transmission method. So this means that the receiver of the data, the reason this happens is because the receiver of the data, which is the receiving computer, will know where the word or the sentence you're sending actually starts and where it ends. This, of course, is being used to prevent a mix-up of data. And without this control bits, you can imagine that data could come out of synchronization, especially when you're sending large amounts of data. The alternative to this type of synchronization data transmission is the one that we call synchronous. This one does not involve the use of control bits. It basically is a continuous stream of data where data is just being transmitted, in a streamwise manner. It's just transmitted continuously. The difference between synchronous and asynchronous is that with synchronous, there are timing signals that are used. So there's an internal clock that is being used that actually determines the time. It monitors the time in which the data is being sent. So there's like a time set in which data sent needs to arrive on the receiving end. So that kind of controls the way data is being transmitted, so it can avoid that out of synchronization problem that normally happens. So the reason we have an internal clock with this method of transmission of data from the sender to the receiver is so that both sides are in synchronized manner. Because then let's say that for each byte of data that is sent from the sender to the receiver, a certain time, like for example, I'm just giving a random example here, guys. So let's say that there's like a 1 minute of a time that is allocated for 8 bytes of data to arrive at the receiving end from the sending end. So that clock basically controls, make sure it does arrive. If of course it does not, there's out of synchronization, then a message is sent back to the sending computer, and of course the data could be resent. So the resent data, so the receiver basically counts how many bits of data were arrived, because they know like after every 1 minute, 8 bytes of data should arrive. So that's the receiving computer. So after every 1 minute, it basically counts the bits that have arrived on the receiving end, and it compiles it together to make sense of it into the message or word. So that's really what happens. So the timing must be very accurate here, since there are no control bits in this type of data transmission. However, as you guys already know, it is a much faster transmission method than asynchronous, and so it is used where it is important, where there is an important issue, for example, with network transmissions, where data has to be transmitted, continuously, because when you're trying to stream something online, you're streaming in a continuous manner. So your the sending and receiving end cannot afford to have things being transmitted in bits and pieces. It has to just continuously be stream online, for example. So this is why it's important in this type of example with network communications. Okay, guys, so we move on to the universal serial bus. So the universal serial bus, as we've already seen, it basically makes use of the serial data transmission method, but it is also asynchronous. So it is asynchronous serial data transmission. So the type of synchronization method it uses is asynchronous, and the type of data transmission method it uses is serial data transmission. It has become a very popular and standard method of transmitting data between a computer and other devices. And a USB consists of a 4-wire shielded cable. 2 of these wires are used for the power on Earth, and then 2 of the other wires are used in data transmission. Now, when a device is plugged into a computer using one of the USB ports, the computer automatically detects that the device is present. Of course, when you plug in your USB to any external port, the computer would detect. And the next thing that you guys might have noticed is at the bottom of your taskbar of your computer, you would see that it says it's preparing the USB, or it will say something like it's installing the required software, or you should be patient for a certain amount of minutes. And what usually is happening is your device is trying to find the device driver, which is the software that is required so that your USB can be functional on your computer system, as in you can use it. So the right device driver, which is the software, would need to be loaded up from your computer so that you can be able to open up the USB and send files to it. So usually at the bottom of your taskbar, you're going to get a notification saying that your USB is now ready to be used. So that means that the required device driver has been installed successfully, and so it allows you to be able to send files to your USB back and forth. So if a new device is detected, the computer will look for the right device driver that matches the device. If it is not available, you will be prompted to download the appropriate application software. So USB has become the industrial standard. There's still a number of benefits and drawbacks of USB. So I'm just going to run through this, guys, so that we can look at the next thing, which is the error checking methods, like I said. So here are some of the good things about the USB. The benefits is that devices plugged into the computer are automatically detected, and the device drivers are automatically installed or uploaded if they're available. The connectors can also fit one way, so this prevents some sort of incorrect connections being made. Again, this has become the industry standard, and so this means that it basically is supported and available to many users. There are several different data transmission rates that are supported, and now newer USB standards are also backward compatible, which means they're also compatible with older USB standards. Some of the downsides of USBs is that the maximum cable length is just 5 meters. That will be, of course, with the USB, the cable that comes with the phone. And the present transmission rate for USB is less than 500 megabits per second. And the older USB, and they give you an example of a version USB 1.1, may not be supported in the near future. Okay, guys, we've come to our main practical part of this unit, and this has to do with the error checking methods. Now, this is one of the most important aspects of this unit because in the IGCSE exams, if you looked at the paper 1 and mostly paper 1, you're going to find out that they do ask questions in terms of parity bits, in terms of the parity blocks, which we're going to see, in terms of how to find checksums and so on. So here there are some practical aspects that you would need to know how to do. This is what we're going to see. So what they're saying for this part of this unit is basically telling you that it is important to understand how data is transmitted in terms of the direction and the data transmission method like what we've seen, and the synchronization method as well. But it is also important to ensure that the data that has been transmitted has arrived correctly. And so what we're going to do now is we're going to be looking at some of the error checking methods that are used to ensure that data has been transmitted correctly. So here it says, following data transmission, there is always the risk of data to be corrupted or changed in some way, especially when it's being transmitted over long distances. So checking for errors is very important since computers aren't able to check text or to know if the text is correct. They can only recognize if the word does exist in their built-in dictionary. And so they give you an example of some rumbled up text here, and they say, can you be able to read this? Obviously, this doesn't make sense to you as a human being. You can imagine to the computer it's going to make completely no sense. So how is the computer able to ensure that data that has been sent from the sending side arrives correctly at the receiving side? So this is why error checking is a very important part of computer technology. And so this section talks about the different numbers of ways that you can use to check for errors to ensure that data arrives correctly. And so a number of methods that exist which can detect errors are basically parity checking, which we're going to see how that works. There's also something called the automatic repeat request, and then there's checksum, and then there's echo checking. So let's start with parity checking, guys. So parity checking is a method of data error, it's an error checking method, which is used to check that data has not been changed or corrupted over transmission from one device to the next. And how does this work? Well, a byte of data, for example, is allocated a parity bit, and this parity bit is usually a 1 or a 0. And this is allocated before the transmission takes place. So that tells you that both the sending and the receiving end have to agree on what their parity bit is going to be before any transmission would take place. So systems that use even parity basically would have an even number of 1 bits, but systems that use, that is, what they're trying to tell you is that when data is transmitted from the sending side to the receiving side, and remember guys, we keep talking about computer systems. We're talking about devices, we're not talking about people. We're talking about data being transmitted from the sending side, whether it's a computer sending that or any sort of device, to the receiving end. And we're saying that before the data is transmitted, using this kind of error checking method called parity checking, both of the sides have to agree what kind of parity method or checking are they going to be using. If it's even parity method, then that means that the data that will be transmitted, that is the bytes of data we're talking about. Because remember, the computer doesn't understand words. Everything in words or sentences would need to be converted into binary. And so that is going to be sectioned into bytes. We know that basically 1 byte is containing 8 bits. So the bytes are going to be sent from the sending end to the receiving end, of course, when data is being transmitted. And if they're using a parity checking error method checking to be able to determine that data arrives correctly from sending to receiving end, then they both have to agree what kind of parity checking method they're going to be using. That is, these devices have to have some sort of agreement over the network connection. So if it is an error parity checking method, it means that the data that will be sent in binary from sending to receiving end should have an even number of ones. If it is an odd parity checking method, it means that the data that will be sent from sending to receiving end should have an odd number of ones. And so that's how the parity check works. So here it says, consider the following byte. As you guys can see, this is 110, 1100. So you can see that there is total, if you look at the number of ones, because with parity checking, you should always concentrate on counting the number of ones. So if we count the number of ones here, we have 1, 2, 3, 4. So that tells us we have 4 ones. And so we don't really know if this has been transmitted correctly or not. We're still missing a bit here. And that's going to be the parity bit. We can only tell if this has been transmitted correctly or not if we know what the sending and the receiving end have agreed upon in terms of the parity checking method before transmission. And so if they agreed upon even parity, for example, if both devices have agreed on sending data in bytes according to even parity checking method, it means that the number of ones in those bytes that will be sent of data should be even number of ones. And so that means in this case, the parity bit here would be 0, because if we put a 1 here, then you will count 1, 2, 3, 4, 5, and that will be odd parity, and that's not what the both sending and receiving ends have agreed upon. They've agreed upon even parity. So that means if you count the number of ones now, you get 1, 2, 3, 4. It's already even, so you need to just put a 0 here so that it stays even. And so that means the data will be sent correctly. So this is pretty much what I've explained is what they've talked about here. They said if an even parity was agreed between the sending and receiving ends, it means that 0 would be placed here so that there's an even number of ones. If the sending device and the receiving device have agreed to use a parity checking method of odd parity, then it means that the number of ones should be odd numbers. So that means 1, 2, 3, 4, 5, basically odd numbers, 5, 7, etc. So now let's do some activities together. So activity 2.2 guys says that we need to find the parity bits for each of the following parity bytes or following bytes. So we have bytes here, byte A, which contains 8 bits, and they said even parity is used. So they're telling you basically if you were going to add, so let's just count 1, 2, 3, 4, 5, 6, 7. So there's 7, they're not complete. There's still a missing byte. A missing bit, sorry. So let me write it out first. So it's basically 1. So this is letter A, right? We're doing A. So it's 1, 1, 0, if I remember. And then there's like a 1, 1 again. And then there's a 0, 1, right? So if we count this, we have 1, 2, 3, 4, 5, 6, 7. So this is made up of 7 bits, which does not make a byte because we know that 8 bytes basically make 8 bits, sorry, basically make 1 byte. So that means that it has to have there is a missing bit that is supposed to be here at the beginning, which we don't know what it is. So 8 bits basically gives you 1 byte. Always remember, 8 bits is 1 byte. And currently what we have here is just 7 bits. So the question is asking you that, let's say this incompleted byte of data is sent from a sending end to a receiving end. But both the sending end and the receiving end have agreed to use even parity. And so what you can see is that if they agree to use even parity, it means that the number of ones in this byte should be even. So that means we need to check and see if the number of ones are even. So let's see, we have 1, 2, 3, 4, 5. And we see that this is odd, so this is not even. So the question is asking you what bit at the beginning, of course, which is where the missing bit is supposed to be, what bit here should be put, whether is it a 0 or is it a 1, that should be put in this missing box so that the number of ones are even. And so that would mean that there is actually a transmission using even parity. So the answer to this question will be, of course, the missing bit that should be here should be a, you guys can tell, right? Because it's 1, 2, 3, 4, 5. So it should be a 1. Because if you put a 0, then you're still going to have an odd numbers of ones, which does not make use of even parity, but rather it uses odd. If it wants to make use of even parity between the sending and the receiving end, then there should be a 1 here, which would complete the number of bits to make it a byte, and at the same time, it will also achieve the rule of even parity. So now if you count, you get 1, you get 2. You always have to count the ones, guys, so that you know if the parity is even or odd. So you count the ones, you start with this one, 1, and then 2, and then 3, and then 4, and then 5, and then 6. So you see that we now have 6 bits of 1, 6 1 bits. So basically 6 1 bits can already tell us that this type of transmission is making use of even parity, which indeed is following this rule here. So the answer to this question would be 1. So the missing parity bit is basically 1. So this 1. Okay, so the next one is also another incompleted bytes, which we can see is 3 zeros, and then we have 4 ones, so it makes a total of 7 bits. We're still missing 1 parity bit, and we can see that there's 1, 2, 3, 4. So we see that the number of ones, because you always have to count the number of ones, is already 4, which means it already achieves an even parity. So the missing parity bits in this case is just going to be a 0. So if we go back, let's write it out here. And that will be our number B, or letter B rather. And we have 0, 0, 0, and then we have 4 ones. So that means the question is asking us what again is going to be the missing parity bit here, because we have to complete it to make it a byte. And it also tells us that this transmission is using even parity. So that means that you have to count the number of ones and see if they're even. So we have 1, 2, 3, 4. It is even, so that tells us that we cannot add an extra 1 here to, complete the missing parity bit. Obviously, this is going to be a 0, so that we still keep the number of ones as even. So the answer to this question is going to give you 0. We'll do one more for odd parity, and then we'll move on to the next part. So for letter D, it says that this type of transmission is using odd parity. And as you guys can see, again, it is made up of 7 bits, which is not complete. So here we have 1, 2, 3, 4, 5, 6, 7. And so they're telling us that this transmission uses odd parity, but is it correct? Is it transmitted properly? So what is the missing parity bit? So the same thing again for question C. So we're going to write it here. The bytes is basically question D, guys, sorry, because we're doing odd, is 1110100. So this is question D. And so it's 1, and then you have 1 again. So there are 3 ones. And then you have a 0, and then you have a 1, and then you have a 0, 0. So if you count this, you have 1, 2, 3, 4, 5, 6, 7. So you have 7 bits, and the question's asking you what again is going to be the missing parity bit here at the beginning so that it achieves a data transmission parity checking of odd parity. So that means you need to count the number of ones and see if they're odd number of ones. So let's see, 1, 2, 3, 4. We see that the number of ones are not odd, but rather even. So this does not achieve an odd parity, but an even parity. So that means for it to achieve an odd parity, the missing bit here is going to be another 1. So that when you count the total number of ones, you get 5. So 1, 2, 3, 4, 5. So that tells you it does achieve an odd parity bit because you now have 5 bits of ones. Okay? 5 bits of ones, or you could say 5 1 bits. So this is how you answer such questions, and I wanted to show you from some past papers. This is from past paper IGCSE of 2019. This is a question that's been asked, and it says, The contents of 3 binary registers has been transmitted from one computer to another. It says odd parity has been used as an error detection method, and the outcome after transmission is register A and B have been transmitted correctly, but register C has been transmitted incorrectly. They say you should write the appropriate parity bit for each of the register to show the given outcome. So here, guys, it's telling you that A and B have been transmitted correctly, but it also tells you that the kind of parity checking method that has been used between these registers in transmission of data is odd. So it says register C has been transmitted incorrectly, and basically they're asking you to put the right bits based on this information. So if you look at register A, you first have to count the number of ones, and as you can see, there's 1, 2, 3. So there are already 3 numbers of ones, which means 3 is an odd number. So this means that register A, as they said, is transmitted correctly, and so the missing parity bit will be a 0. And now if you look at register B, you count the number of ones, you get 1, 2, 3 as well. So that tells you it's already achieving an odd parity. So the missing parity bit is again going to be a 0. If you look at register C, it says it's transmitted incorrectly. So let's see, because it has just 2 ones, which means it's even parity, not odd. So the missing parity bit is just going to be 1. Okay, guys, so this is an example for question 5 that comes out with the IGCSE exams that focus on parity bits checking. Okay, let's go back and see what we can do some more before we end our video tutorial. So here it says if a byte has been transmitted from A to B and even parity is used, an error would be flagged if the byte now has an odd numbers of ones at the receiver's end. So this is a sender's end, and this is an example of a receiver's end. So we have 1, 2, 3, 4, and we have 1, 2, 3. So of course, if they have initially agreed to even parity being used, and at the end of the day, the receiving end does receive bytes of data that comes in an odd parity, not an even parity, an error will be flagged. And of course, that would mean that they would have to be some sort of resending of data. So in this case, the receiver ends, like I said, has 3 bits, which means it now has odd parity, whilst the byte that was sent was even parity. So this clearly means that an error has occurred during data transmission. And so the error is detected by the computer by recalculating the parity of the byte sent. And if even parity has been agreed, then a change of parity in the received byte indicates that the transmission error has occurred. So there will be a flag of errors, guys. Now in activity 2.3, it says which of the following bytes have an error following data transmission. And so what they want you to do here is look at this bytes of data that is complete. This is a complete byte because, as you guys can see, it's made up of 8 bits of ones and zeros. And they're asking you to say which one has an error. So the first one is transmitted using even parity. So you need to check the number of ones and see if it has been transmitted correctly. So if we count, it is 1, 2, 3, and then 4, 5, 6. So that means that this has been transmitted correctly. And so you do the same step with the next one, and you check what kind of parity is used. It says even parity. You need to count the number of ones and see if they're even. So we have 1, we have 2, 3, 4, 5. This tells you that this byte of data is not transmitted correctly because the number of ones are not even, but they're odd, and so on. That's what you're going to do pretty much with the rest, guys. So even though parity checking is a very good method of checking if data has been transmitted correctly or not, but the problem with this kind of method of checking is that, yes, it does say if there's an error that has occurred, if the parity check is not correct, but it doesn't exactly tell you where in the data that has been transmitted the error has exactly occurred. I mean, it doesn't say that it has occurred in a specific position. It's occurred here or it's occurred here. With parity checking, it just looks at the byte of data that is being sent and just tells if there's an error or not, but it doesn't say where exactly. Now, to solve that problem, to be able to specify where exactly an error has occurred, we will need to use a different type of error checking method that is also under parity checking, but we will need to make use of parity blocks. And so this would mean that in this case, a block of data would be sent. That means that the number of ones are going to be totaled horizontally and vertically in a tabular form. So that is the next type of parity checking method that we're going to use so that it exactly determines where an error has occurred, if it has occurred, when data has been transferred or sent. So we're going to be looking at how parity blocks work But for now, guys, I will have to stop the video tutorial here. And so in the next video tutorial, I will be showing you guys how parity blocks work, and we will be looking at the remaining types of error checking methods, which then go to the automatic repeat request. And then, of course, we will be looking at checksums, which is another thing you need to know how to calculate and find. And then we will move on from there. Thank you guys. I hope this video has been useful to you. Stay tuned for the other video that I will be recording as well and posting at the same time with this one that shows you how to be able to solve the IGCSE Past Paper 2, which involves programming. Have a great day, everyone.